We'll look at another example on parametric equation and finding d2y dx squared. And of course, before you find d2y dx squared, you have to find dy dx. So in this question, you ask to show dy dx is tangent t, and then you ask to find d2y dx squared. First, you will find dx dt. Dx dt, differential 1 gives you 0. Differential cosine will give you negative sine 2t. Differential 2t will give you a 2. So dx dt will be 2 sine 2t. Next we shall find dy dt. Dy dt, differentiate 2t will give you 2. Differentiate sine 2t will give you cosine 2t. And differentiate 2t will give you a 2. So we just minus 2 cosine 2t. We just copy the minus sign down. And then we can find dy dx. Dy dx would be dy dt then divided by dx dt. So it's just 2 minus 2 cosine 2t over 2 sine 2t. Yeah? You can take out 2 and cancel, so it becomes 1 minus cosine 2t over sine 2t. And if you look at the question asks you to show is tangent to t, tangent t. dy dx is tangent t. So which means you have to simplify this. And we make use of this. Sine 2a is 2 sine a cosine a. We have this trivial identity. Then you also have cosine 2a is, there are 3 of them, cosine square a minus sine square a, 2 cosine square a minus 1, 1 minus 2 sine square a. And you can see which one is useful. You want to change it such that the 1 will disappear. So it must be 1 minus 1. So that means it needs this to be useful. You should replace it by 1 minus 2 sine square a. So that when I start in, the 1 will disappear. You can try out this one will not work. So you sub cosine 2t by 1 minus 2 sine square t. Then sine 2t, you change it to 2 sine t cosine t. And you'll find that 1 and 1 cancel. If you extend up 1 and 1 cancel, so it gives you 2 sine square t over 2 sine t cosine t. Sine 2t is 2 sine t cosine t, which I just mentioned here. So sine 2t replaced by 2 sine t cosine t. And then after that 1 cancel, right? Then you can cancel 2. Sine square t is actually sine t and another sine t. So one of them will cancel with the sine t. So which means you're left with sine t over cosine t. So you're left with sine t in the numerator and cosine t, which gives you tangent t. So this will simplify to tangent t, which is what you want to show. So that will be the first part. And second part, you want to find d2y dx squared. So we have dy dt is tangent t. Then we also have dx is 1 minus cosine 2t, and dx dt is 2 sine 2t. So let's copy this here. So dx dt is 2 sine 2t. Dx dt is 2 sine 2t. Then you want to find d2y dx squared, which you can change it to d dt dy dx, and multiply by 1 over dx dt, the formula I mentioned, which is the formula I mentioned earlier. This one. To find d2y dx squared in parenthetic differentiation, change it to d dt dy dx, multiply by 1 over dx dt. Okay, so the next is d dt and dy dx. dy dx, the answer we have found is tangent t. So it makes sense. So it makes sense to differentiate tangent t. Because if you try to differentiate dy dx directly, you'll find that you can't, because dy dx is in terms of t. dy dx is in terms of t. So you are given, you just show that dy dx is tangent t. So to find d2y dx squared using the formula I mentioned, is d dt of dy dx times 1 over dx dt, and it makes sense because d dt tangent t you can find, and multiply by 1 over dx dt, which is just 2 sine 2t. So 2 sine 2t. Differentiate tangent will give you secant square t. And now multiply by 1 over 2 sine 2t. Sine 2t, you can change it to 2 sine t cosine t, the formula for sine 2t. Trigo formula, sine 2t is 2 sine t cosine t. So with that, it will give you 2 times 2, 4. It gives you 1/4. And remember, 1 over sine theta gives you CSC cosecant theta. 1 over cosine theta gives you secant theta. So here you should have another CSC t secant t. So total is 1/4. Final answer is 1/4 secant cube t cosecant t. So this will be the final answer to d2y dx squared. So remember, to find d2y dx squared, you can't differentiate dy dx with respect to x. So differentiate with respect to t, and then multiply by 1 over dx dt. And so the final answer is this.